Hello class, and welcome to this video lecture on polyatomic ions. Okay, so class, if we look at this word polyatomic, poly means many, right? So polyatomic ions are ions that are made up of many atoms, okay? So several atoms get together and bond. We'll see how that happens a little bit later. And as a group, they either gain or lose one or more electrons to form an ion. Okay, so let's look at some of the formulas of the important polyatomic ions that we need to learn. Okay, NH4 plus, okay, this ion is called the ammonium ion. Okay, now again, as I described, when you see this, the way we interpret this is that one nitrogen and four hydrogens got together, bonded, okay, and as a group lost one electron. So this plus one charge doesn't apply to the hydrogen, it doesn't apply to the nitrogen, it applies to the whole grouping of elements to form this polyatomic ion. Okay. All right. Cn minus, this is another important one. This is called the cyanide ion. Okay, so here, again, this -1 charge, it doesn't belong to the nitrogen, it doesn't belong to the carbon, it belongs to the group. A carbon and a nitrogen bonded together, and together what gained an electron. That grouping of atoms gained an electron. Now we'll see how that happens a little bit later, but that's how we interpret that, okay? All right, OH minus, this is a very important one, okay? The hydroxide ion, those of you that have heard of acids and bases, okay? So bases produce hydroxide ions in an aqueous solution. So this is a very important polyatomic ion. All right, C2H3O2 minus is the acetate ion. NO3 minus is the nitrate ion. ClO3 minus is the chlorate ion. MnO4 minus is the permanganate ion. OCN minus is the cyanate ion. SCN minus is the thiocyanate ion. HCO3 minus is the bicarbonate ion. Okay, so we come over to the next column here. HSO4 minus is the bisulfate ion. CO3 2 minus is the carbonate ion. Okay, we've got the sulfate ion. Okay, this is the oxalate ion, the chromate ion, the dichromate ion, the phosphate ion, the hydrogen phosphate ion, the dihydrogen phosphate ion, and the thiosulfate ion. Okay? Now, class, there are thousands of polyatomic ions. Thousands, okay? We don't need to learn thousands of them, but we do need to learn a few of them. We'll need to learn these, and we'll need to learn ions that are associated with these, okay? So we'll talk about that here in just a little bit. Now, let me point out some important items here in dealing with these polyatomic ions and the names, okay? The prefix thio, when you see thio, that means replace one oxygen with a sulfur, okay? Let me show a couple of examples of this, okay? So the cyanate ion is one that we need to learn, okay? When we see this prefix thio, okay, what that means is we replace one oxygen with a sulfur. Well, this only has one oxygen. If we replace that with a sulfur, we get the thiocyanate ion, okay? So, by learning this guideline here, by memorizing the cyanate ion, you'll know the thiocyanate ion if you follow this guideline. That's what thio means, okay? Let's look at another example. The sulfate ion, okay? If we want the thiosulfate ion, what do? We replace one oxygen with a sulfur. So we're going to pull one oxygen out of here and replace it with a sulfur. That will give us this, S2O3 2-. Okay, the thiosulfate ion. Notice, class, we don't change the charge. The charge stays the same. We simply replace one oxygen with a sulfur. Okay, so that's what thio means. Now, the prefix bi means hydrogen. Okay, the prefix bi means hydrogen. Let's look at some examples of that. So here's the carbonate ion. The bicarbonate ion is HCO3-. Okay, bicarbonate. Now, class, we could call this the hydrogen carbonate ion. That would be okay to call it that. A lot of times it's just referred to as the bicarbonate ion. We can take the sulfate ion, okay? The bisulfate ion is what? We put a hydrogen here in the front, okay? So we could call this the hydrogen sulfate ion. Now, class, if you've looked at this, you might notice, you might say, hey, you not only put a hydrogen in there, but you changed the charge, right? That's exactly right. Notice in going from here to here, what did I do? I put a hydrogen here and I added one to the charge. Okay, did the same thing here. I increased the charge by 1, went from a -2 to a -1. So what's happening here, class? What we're really doing is we're not just adding a hydrogen, we're adding a hydrogen ion. Okay, we're adding a hydrogen ion with the anion. We're combining it. We're combining a hydrogen ion with this to give another anion. Okay, so if we look at this, if I take the carbonate ion and I combine it with a hydrogen ion, okay, this is what I get. I not only put a hydrogen there, but what do I do to the charges? I add the charges together. Okay, I've increased the charge by 1. That's the bicarbonate ion. Okay, you know where we get hydrogen ions in the lab? Oftentimes from acids. Okay, so hydrogen ions. Now let's look at the sulfate ion. Okay, if we take a hydrogen ion and we combine it with the sulfate ion, again, we're gonna put a hydrogen in the front. What do we do to the charges? We combine the charges to give a -1. Okay? So by learning these two guidelines here, class, that will help you in learning the formulas for these polyatomic ions. Now, we typically do not use the prefix bi with the phosphate ion, okay? And the reason for that, class, is because we can add more than one hydrogen ion to this, okay? If we add a single hydrogen ion to this, okay, we put a hydrogen in the front, we add one to the charge, we call this the hydrogen phosphate ion. We don't call it the biphosphate ion. We call it the hydrogen phosphate ion. And the reason for that is because we can add a hydrogen ion to this, right? If I take this and I add a hydrogen ion to it, I'm going to have another hydrogen and I increase the charge by 1. We call this the dihydrogen phosphate ion. We don't call this, what does di mean? Di means 2, right? Dihydrogen, we've got 2 hydrogens here. We don't call this the biphosphate ion, because then what would we call this? If we call this the biphosphate ion, what would we call this? The dibiphosphate ion. It just sounds a little odd. Okay, so we typically don't use bi when we're talking about the phosphate ion. Okay. All right. Now, class, there's a very important series that that we use when naming polyatomic ions. So I'd like to show that to you. Okay. I'm going to show you in the context of the chlorate ion. Okay. So this is the chlorate ion. This is one of those important ions that we need to learn. Now, this, class, is the chlorite ion. Okay. ClO2 minus, all I did was what? I'm using one fewer oxygen. I didn't change the charge. Okay. Anytime you see the suffix ite, ite means one fewer oxygen than the ate. Okay. So if this is chlorate, chlorite will have one fewer oxygen. Okay. So this is a key ion here, class, to memorize. If we memorize this, if this is the chlorate ion, and then we keep in mind the guideline that when we use ite, that's one fewer oxygen than the ate, we'll have two ions. Okay. Now, look at this. Okay. ClO minus. What if I take away another oxygen? Well, that's called the hypochlorite ion. What does hypo mean? Hypo means low, right? Low or lower, hypo. Okay, so anytime you see hypo and then ite, that means one fewer oxygen than the ite. Okay? One fewer oxygen than the ite. All right, so we got chlorate, chlorite, hypochlorite. Okay? Now, what is the opposite of hypo? Hyper, right? Well, let's look at this. If we have one more oxygen than the chlorate, we don't call it hyper, okay? It's called perchlorate. Okay? Now, class, I didn't come up with the naming system for these, okay? So I'm just showing you the method. This is like learning a different language, right? We're learning the language that chemists use here, okay? So perchlorate, anytime you see per, the prefix per, that means one more oxygen than the ate, okay? So class, among these four ions, which one is the most important one for you to memorize as you're trying to learn these? You need to memorize this one. This is the key ion. And then we need to learn the method to the madness, so to speak, right? If we go ite, that's one fewer oxygen. We go hypo, that's one fewer oxygen than the ite. We have perchlorate, that's one more oxygen than the ate. Okay? So this is the method. Now, you all know this. This is not a polyatomic ion, right? It's not a polyatomic ion. It's an ion that has chlorine in it. You remember how we named that? We call that the chloride ion, right? A monatomic anion ends in IDE, doesn't it? A monatomic anion ends in IDE. So that's the chloride ion. Now, class, there is a similar series of this naming scheme for the bromine and iodine containing polyatomic ions. Chlorine, bromine, iodine, they are all halogens, aren't they? They're all in the same group. So we have a very similar naming scheme for polyatomic ions involving bromine and iodine. Okay, so for example, if you see this, okay, BrO3 minus. That looks a lot like this, right? The only difference is there's a bromine instead of a chlorine. What did we call this? Chlorate. We call this the bromate ion. The bromate ion. So we have bromate, bromite, perbromate, hypobromite. We've got all the same ions, okay? Similar types of ions that we have here. What about this? What if we have IO3 minus? If this is chlorate and this is bromate, what do you think this is going to be? It's going to be iodate, the iodate ion. Okay, those are all in the same group. They're all in the same group in the periodic table. Okay, what do you suppose this would be? This is bromate. What's the difference here? One more oxygen. What would that be? Perbromate. That's the perbromate ion. Okay. We've got iodate. What do you think this would be? If IO3 minus is iodate, what would IO2 minus be? Iodite. IO2 minus would be iodite. What would this be then? This would be the hypoiodite ion. Okay. So class, this is where this naming scheme comes in very, very handy for us. Okay. I mean, this is the ion to memorize. Okay. If you memorize this, okay, and then if you learn this scheme, this naming scheme, you'll know, class, how to name, 12 different polyatomic ions, right? 1, 2, 3, 4, the bromine, the iodine series, okay? Because it's a similar naming scheme for those, okay? So this is the system here, okay? Now, let's look at this, class. Other ATE, ITE scenarios here, okay? So we've got the nitrate ion. We've got the sulfate ion. We've got the phosphate ion, right? Those all end in ATE. Okay, let's take the sulfate as an example. If this is the sulfate ion, what would this be? Based on what we've talked about on the previous slide. This is sulfate. What's the only difference? I didn't change the charge. There's one fewer oxygen. What would this have to be? The sulfite ion, right? And if this is the sulfite ion, what would this be? What's the only thing I did? What's the only difference between these? This has one fewer oxygen. The charge is the same. If this is sulfite, what would this be then, based on what we had on the previous slide? This would be the hyposulfite ion. The hyposulfite ion, okay? Now, class, this is not a polyatomic ion. This is a monatomic anion. What do we call that? From sulfur, we get what? The sulfide ion. Not really a polyatomic. I wanted to put it on the slide because it's a sulfur anion. Okay. All right. Now, class, what would this be? Let's look at this. This is sulfate, right? We went from sulfate to sulfite, one fewer oxygen. If this is sulfite, what would this be? What did we say, hydrogen? What did we do? We put a hydrogen in and we added one to the charge, right? To get from here to here, we added a hydrogen and we added one to the charge. What would this be? The bisulfite ion. The bisulfite ion. You see how that works? Okay. Now, memorizing polyatomic ions. Memorizing polyatomic ions. You might be saying, where in the world do I start? Okay, well, class, look. Different people take different approaches to learning these polyatomic ions, okay? I'm going to give you a suggestion. You can follow my suggestion if you'd like to. What some students do, they just put these on note cards and they start memorizing, okay? There's another approach that we can take, okay? There's another approach that we can take. I'm going to suggest it to you. Again, you can heed my suggestion or not. I would start, if you've never had chemistry before and you're trying to learn these, I would start with these 5. Okay, we need to know all of these, but I would start with these 5. These are what I call key ions. These are 5 key ions, okay? So let's look at these just a moment, class. And let me point out some things here. What do all of these have in common? Let's look at the formulas first. What do all of these have in common? Well, let me point out some things. They all have some number of oxygens, right? They all have some number of oxygens. They all have a nonmetal in there. They're all negatively charged. And they all end in ATE, don't they? Looking at the name, okay? So let's look at this. Okay, so can we say that if a polyatomic ion has 3 oxygens in it, it's going to end in ATE? Can we say that? No, we can't, because these have 4 oxygens in them, and they end in ATE, so we can't really say that, okay? Well, okay, let's look back up here at nitrate. Can we say that if it ends in ATE, it's going to have a -1 charge? Is that true? If it ends in ATE, it's going to have a -1 charge. No, that's not true, because these have a -2 charge. This has a -3 charge, okay? So we can't say that. Class, let me tell you something else you can't do. You can try it. I don't suggest it. It doesn't work. Okay, you can't find nitrogen and oxygen in the periodic table and determine what the charge is going to be. You can't say, well, nitrogen is going to combine with 3 oxygens and it's going to have a -1 charge. You can't do that. It doesn't work that way. I mean, you'll see why as we get a little bit farther along in the course. That won't work. So what do? Well, you just got to memorize these, okay? Memorize these. Learn these 5. Learn these 5. That's what I would do to start with. I would commit these to memory. These are very important ions. And then I would remember some of the points that we mentioned. Thio means replacing 1 oxygen with a sulfur. Bi means hydrogen, right? You're adding an H+. Okay? Then you need to remember that chlorate series. Okay? Now, class, it's true, there are some ions that, don't really seem to be in a series with others, like the hydroxide, it's not really in a series. The acetate ion, it's not really in a series. Some of these, you just have to use brute force memorization, okay? But class, let me point out, it is very important that you learn these, okay? Because we're going to be using these, okay? We're going to be using these. These are like learning words, okay? You think about learning a new language. Think about how you learned, your language. I'm assuming that, you've learned English, right? Most of you are English speaking. Some of you, English is probably not your native language. But, you first started learning the letters, right? And then you learned words, right? And then you learned how to put sentences together, very basic sentences. Well, we're trying to learn the language of chemistry, and we're going to need to know these polyatomic ions, okay? So this is what I suggest you do to start, okay? If you've never had chemistry before and you're just kind of, learning this now. Now, we take these ions and we put them together to form compounds. Remember when we talked about binary ionic compounds? We put together, cations and anions, from a metal and a nonmetal. Well, here we can put together polyatomic ions. Okay? So look at this. For example, write the formula for magnesium nitrate. Okay? Well, there's the magnesium ion. It's in group 2A, right? Magnesium. The nitrate ion looks like this. We've got to combine them to get an electrically neutral unit, don't we? Okay? So for every magnesium, we're going to need 2 nitrates, right? I'm looking at the charge. I got a +2 and a -1. A 1-to-1 won't work. I'm going to have 2 nitrates. Okay? So this is the way I would write that. Okay? I have to put the nitrate, the NO3, in parentheses. What this means, class, remember, you always write the cation first. You write the cation first and then the anion. We use parentheses when we have more than one polyatomic ion. That's very important. You use parentheses when you have more than one polyatomic ion. So when you see the parentheses and you see this 2, it means I have 2 of whatever's in the parentheses. Okay? So I've got 1 magnesium, I've got 2 nitrates. That's how we write the formula for magnesium nitrate. Okay? Let's look at another example here. What if we want to write the formula for magnesium sulfate? Okay? So the magnesium ion, the sulfate ion is SO4 2-. Okay, here, a +2, a -2, those cancel each other, don't they? They neutralize each other in terms of the charge. We've got an overall 0 charge when we combine those in a 1-to-1. There you go. MgSO4, magnesium sulfate. You write the cation first and then the anion. Okay? We do not write it like this. You do not use parentheses. What did we say the rule was? You use parentheses if you have more than one of the polyatomic ion. We only have 1 polyatomic ion, so we don't use parentheses. Okay? Use parentheses around the polyatomic ion only if you have more than one. Okay? All right. Let's look at another example here, class. Another example. Okay. Write the formula for calcium hydroxide. Calcium hydroxide. So calcium is in group 2A, forms an ion with a +2 charge. Hydroxide is OH-. These will not combine in a 1-to-1, right? The charges have to cancel. Okay. So we've got a +2, we've got a -2. These are going to combine in a 1-to-2 ratio. Okay. 1 calcium, 2 hydroxides. I have to use parentheses, right? Have to use parentheses here. Calcium hydroxide. Okay. So class, this video lecture, I tried to show you some of the aspects of polyatomic ions. We need to learn all of these polyatomic ions that were on the list and some related to those through using that chlorate series, the ATE, the ITE, and so forth. Okay? It's very important that you learn these. I suggest, if you have not had chemistry before, you might want to use the suggestions that I gave you. Start with those 5 ions, okay, and learn those, memorize those, and then learn the methods for thio, bi, the prefix bi, the chlorate series, ATE, ITE, and so forth, and I think that will help you. And then you need to practice. You need to practice writing formulas with these polyatomic ions and naming compounds with these polyatomic ions. Okay, so I hope that you have found this to be helpful to you in your quest to learn these polyatomic ions.